Hey guys, and welcome back to NASA at Home, where we bring NASA home to you. Today, we're gonna take a look at what it takes to send spacecraft like rovers and landers to Mars, and check out our newest Mars 2020 rover named Perseverance. But first, let's find out how much you know about Mars. Come on. So, there are 8 planets in our solar system. How many planets away from the sun is Mars? Is it A, the first planet from the sun, B, the 6th planet from the sun, or C, the 4th planet from the sun? If you said C, the 4th planet from the sun, you'd be correct. Mars is located between Earth and Jupiter. Now, Earth has 1 moon, but some planets have no moons at all, and others have dozens of moons. How many moons do you think Mars has? 1, 2, 14, 79? If you guessed 2 moons, you're right. The 2 Martian moons are Phobos and Deimos. Now, do you think Mars is bigger or smaller than the Earth? And what about our moon? Is Mars bigger or smaller than the moon? Mars is about half the diameter of the Earth, but it's about twice the diameter of the moon. Mars has about 1/10 the mass of Earth. And because it has less mass, that means that it has less gravity, about 62.5% less than you're used to here on Earth. In fact, if you weighed 100 pounds on Earth, you'd weigh only 38 pounds on Mars. That's sure one way to lose weight. Too bad your mass doesn't change, though.
Alert, alert, alert.
Now, we know Earth is the 3rd planet from the sun, and it's about 93 million miles away from it. But of course, Mars is the 4th planet from the sun, so naturally it's further away. Mars is about 142 million miles from the sun. Being further from the sun means its orbit is a longer path, so a year, or the time it takes to make one trip around the sun, is almost twice as long on Mars as a year on Earth. Now, people are always talking about living on Mars, but what would it actually be like? How easy would it be to survive? The atmosphere on Mars is mostly carbon dioxide and extremely thin, without enough oxygen for us to breathe. There's no liquid water on the surface to drink either. The landscape is freezing with no protection from the sun's radiation or from passing dust storms. The keys to survival will be technology, research, and testing. Like Earth, Mars has volcanoes, gullies, and flat plains. Scientists can also see channels that look like they were carved by rivers and streams a long time ago. These are areas we want to explore for signs that life once may have survived there. So, how do you get to Mars?
How do you get to Mars? If you want to send a spacecraft all the way to Mars, first you'll need a fast rocket to escape the pull of Earth's gravity. The heavier your spacecraft, the more powerful your rocket needs to be to lift off. Next, make sure you launch at the right time. Mars and Earth orbit the sun at different speeds and distances. Sometimes they're really far apart, and other times they come closer together. About every 2 years, the 2 planets are in perfect positions to get to Mars with the least amount of rocket fuel. That's important. The total trip is over 300 million miles. Finally, make sure your aim is right. You can't shoot for where Mars is at launch time. You have to aim for where it will be when you get there. It's a lot like how a quarterback passes a football. Also, you may need a few thrusts to correct your direction along the way so you don't miss Mars. If all goes well, you'll get to the red planet in about 7 or 8 months. Then, if you actually want to land on Mars, well, that's a whole other challenge.
What do we send to Mars? Since the 1960s, scientists have been sending spacecraft to Mars. Several different types of spacecraft have been sent to the red planet over the years, and they all have different specialities. The first missions to Mars were flyby missions that took photos and measurements as they passed by the planet. Next, we sent orbiters, which orbit Mars, taking pictures as they zoom around the planet. Other robots we send include landers, which provide photos and scientific information from their landing spots on the surface of Mars. InSight is the lander currently on Mars, sending back data and giving us insight into what the inside of Mars is like. And the last type of spacecraft we send are rovers. Rovers have wheels and specialize in moving around. They land on the surface of Mars and drive around to different locations and help scientists in their quest to understand how the planet formed and evolved into its current state. Over the years, we've sent 4 rovers to learn more about Mars: Sojourner, Spirit and Opportunity, and Curiosity.
The Perseverance rover, as part of the Mars 2020 mission, will launch to the Red Planet as early as July 30th, 2020.
So, why are all the people working on Perseverance wearing clean suits and masks? Well, let's meet one of the scientists who can explain to us why it's so important to keep things clean when we're building any type of spacecraft to send to another planet or celestial body.
It's really important that we send a rover that's clean and we make sure that it doesn't contaminate Mars. My name is Mujige Stricker and I protect Mars from Earth bacteria. The next Mars rover is slated to go to Mars, collect samples so that eventually we can bring those samples back to Earth and determine for the very first time, did life exist on Mars? There's nothing that we can build that's sterile. So we take swabs and wipes of the spacecraft as it's being built. It gets put in an oven, it gets put in various chambers and clean rooms so that we can maintain that level of cleanliness. If we do find something on Mars, we have to make sure it's something that actually came from Mars and not something that hitched a ride. This is the place where the magic happens. Oh, it's definitely cool. In this lab, we look specifically at spores. So spores are those hardy microorganisms that can actually survive if it made it on the spacecraft in the journey through space, through the vacuum. It's very humbling to be a part of this big project because there are hundreds of people that have to come together and build a spacecraft. There's no one person that can say, I did this, I made this happen. It's always a we. I owe it all to Carl Sagan and watching the cosmos. I remember being a little kid, going to the public library and renting that VHS. And from that moment, the light bulb turned on. It actually was the start of my passion of science communication. We are citizens of our universe. We have to be good ambassadors when we are exploring other planets, other moons. So it's the right thing to do.
But how exactly do you land on Mars?
How do you land on Mars? Very carefully. Your spacecraft hurtles toward the planet at thousands of miles per hour, so you'll have to hit the brakes in a hurry. First, your capsule needs a heat shield. It protects the spacecraft inside from the heat and friction of entry into the atmosphere. Friction slows you down over 90%, but not enough to land safely. Use a parachute to slow down even more. Still, falling at over 100 miles per hour, you need the right system to land safely. Here are some options. With a small to mid-size rover, use a cushion of airbags along with retro rockets. Impact at 30 miles an hour and bounce to a stop. With a large lander, use retro rockets and landing legs to touch down going about 6 miles an hour. Or with a large heavy rover, use a big jetpack to slow down to under 2 miles an hour. Then gently lower it on cables to land on its wheels. Any way you do it, you'll need skill and hard work. There's nothing easy about landing on Mars.
You can practice landing your own spacecraft on target like an engineer using things you can find around the house. Here's my friend Oda to tell us more about it.
Hi, this is Oda from NASA's Jet Propulsion Laboratory. Today we're going to learn a little bit about how NASA lands spacecraft on planets and moons. And then we're going to try our hands at it ourselves with objects we have lying around the house. Landing on another planet that is constantly in motion, rotating on its axis and revolving around the sun can be tricky. Spacecraft like NASA's Perseverance Mars rover travel really fast through space toward a target landing spot on the surface of a planet, in this case, Mars. Because the rover will be landing by itself with no real-time help from people on Earth, scientists and engineers must do a lot of work in advance, understanding the forces and motion involved, and then programming the computer to make sure the rover lands at the right spot. NASA's Artemis program will launch astronauts from Earth to a moon-orbiting gateway station. From this gateway, astronauts will fly on a lunar lander to land on and explore the moon. As you can see, it's necessary to understand the motion of all the objects involved: the spacecraft, the lander, and the planet. Now, let's set up a challenge for you to try this at home. You'll need a few materials. about 9 feet of string, or anything string-like, so fishing line or dental floss will also do, a disposable cup, a paper clip, some tape, scissors, and a marble or other object that will serve as your lander. You'll also need a target of some sort. Print out our template or make a target of your own. Set up a zip line by tying the ends of the string to 2 chairs, or use a door handle in a chair. One end of the string should be higher than the other. The more slanted your zip line, the faster your spacecraft will travel. Place the target on the floor under the zip line, about 2 feet from the low end. Use the paper clip to hang your spacecraft cup from the zip line. Make sure the cup and paper clip can slide freely from the top of the zip line to the bottom. Now it's time to design and build your spacecraft. Figure out how to modify the paper cup to carry the marble down the zip line to land on the target using the materials you have on hand. Will the marble travel inside the cup? Outside of the cup on a platform? Underneath it? How will your spacecraft release the marble lander while zipping down the line? Consider whether you will use an automatic release system or a remotely activated release system. If you'd like, you can use additional string tied to your cup to create a remotely activated release system. Now, test your design. Release your cup at the top of the zip line and try to land your marble on the target while your spacecraft is moving. Use the numbered rings on your target to keep track of your accuracy. Repeat your runs several times to get consistent results. Now, think of how you might improve your design. Make a modification and try the experiment again. Keep making modifications and testing your design after each one to see how accurate you can get. Can you consistently get a bullseye? Getting close to the center of the target is what NASA engineers must do when they land a spacecraft on another planet or on the moon. Keep in mind, this is a really tough challenge. Don't get discouraged. Instead, persevere, and even get your family members involved in suggesting ideas.
To check out this activity online, go to the Mars 2020 STEM Toolkit.
So now you know how to land your spacecraft, but how do we choose where to land on Mars?
How do you choose a landing site? So you want to study Mars with a lander or rover, but where exactly do you send it? It's a tricky question for engineers and scientists. You want it all, to land, work, and discover. To land safely means no high elevation sites where there isn't enough atmosphere to slow you down in time. And try to avoid places with steep slopes or big rocks that could damage something. You also don't want to sink into a thick layer of dust. Working is easier near the equator, where seasons aren't so extreme and where solar panels can get lots of sun. And of course, don't send a rover somewhere it can't drive. Most important is what you want to discover. Some sites are great for studying rock layers, others might be perfect to listen for quakes. Using Mars orbiters, you can collect lots of data on potential sites. When you find the best spot to land, work, and discover, you've found your new home on Mars.
Perseverance will land in a region of Mars called Jezero Crater. This crater is interesting to scientists because it may have once been the site of an ancient river delta. The rocks in this region could tell us about the history of the red planet. Scientists believe it might be possible that life existed a long time ago on Mars. But if that were the case, they'd probably be teeny tiny little organisms. Something like bacteria here on Earth. But did life ever really get started on Mars? The Mars 2020 mission hopes to answer that question. The mission will send a rover very similar to Curiosity to explore the rocks, dirt, and air on Mars. Like Curiosity, the Perseverance rover is the size of a small SUV. The new rover has different goals and different science instruments. It will look directly for signs of past life on Mars. We'll even collect samples that can one day be returned to Earth for us to study. The Martian atmosphere is mostly carbon dioxide, which humans cannot breathe. Perseverance will test a method for separating oxygen from the carbon dioxide in the Martian atmosphere. This will help NASA develop the best designs for devices that will provide oxygen for breathing and even for launching rockets to return from Mars one day. Let's meet one of our engineers that builds the rovers that go to Mars.
I'm Aaron Yazzie. I grew up in Holbrook, Arizona, a small town near the Navajo Nation. As a kid, I played outside in the Rocky Desert using my imagination to invent and build things. I graduated from Stanford University with a degree in mechanical engineering. I now work at the NASA Jet Propulsion Laboratory, where I help design and build Mars rovers and landers that play in the desert, just like I used to. For all you students out there with a big imagination, you're already on your way to becoming a great engineer.
Now, once you land the rover on Mars, how does the rover drive? How do you drive a rover on another planet from Earth?
How do rovers drive on Mars? First of all, there's no joystick for driving a Mars rover. Before a rover hits the road, engineers send computer commands overnight, telling it where to go the next day. Depending on how tricky the terrain is, rover drivers have two options. They can send a string of specific commands like drive forward 5 meters, then turn right 90 degrees. The rover turns its wheels enough times to add up to 5 meters and then turns in place. Or if it looks safe, they can let the rover think on its own. They write commands like, see that rock over there? Find your way there safely. Then, using two cameras like human eyes, the rover gets a 3D view of hazards such as large rocks and steep slopes. After mapping the danger zones, it plots the safest route to avoid them. Either way, did the rover complete its drive as planned? Engineers double-check when the rover sends back a postcard of its new spot on Mars.
Did you know NASA's Send Your Name to Mars campaign invited people from around the world to submit their names to ride aboard NASA's next rover to the Red Planet? And in fact, some 10,932,295 people did just that. These names were then stenciled by electron beam onto 3 fingernail-sized silicon chips, along with the essays of the 155 finalists in NASA's Name the Rover contest. On March 16th, the chips were then attached to an aluminum plate on NASA's Perseverance Mars rover at Kennedy Space Center in Florida. Scheduled to launch summer of 2020, Perseverance will land at Jezero Crater on February 18th, 2021.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans. We are always curious and seek opportunity. We have the spirit and insight to explore the Moon, Mars, and beyond. But if rovers are to be the qualities of us as a race, we miss the most important thing: perseverance. We as humans evolved as creatures who could learn to adapt to any situation, no matter how harsh. We are a species of explorers, and we will meet many setbacks on the way to Mars. However, we can persevere. We, not as a nation, but as humans, will not give up. The human race will always persevere into the future. My name is Alexander Mather, and that's why I chose Perseverance as the name of NASA's next Mars rover. I don't really think that there is a word in any human language that can describe the feeling of having your name selected to be part of a mission from the greatest agency in the world, doing the most important things to help humanity spread to the stars. I am 13 years old, and I did not expect that I would be making any form of impact on human space exploration like this until I was at least out of college, or maybe in an internship. And here I am, and I just named a rover. Something I submitted was chosen by people who one day I plan to work with, and that's incredible.
Perseverance won't be the only one heading to Mars. It's taking along a small hitchhiker, Ingenuity, the first helicopter to be sent to the Red Planet. Check it out!
Can we fly at Mars? That has been a question for a long time. This is a huge milestone for us. But really, our job isn't done until we see the same test flight being performed at Mars.
Ingenuity has to be super lightweight in order to fly on Mars. It also needs large blades that can rotate really fast to generate enough lift to overcome gravity in the thin Martian atmosphere. Here's a simple activity you can do at home to build your own helicopter. Okay, to do this next activity, you only need a couple of supplies. You need one sheet of paper, a pair of scissors, and something to write with. So first thing we're going to do is we're going to take our piece of paper and we're going to make it the correct size. So we're going to fold it in half, top to bottom, and then you're going to want to crease that really nicely so that we can either tear or cut along that crease. So you're going to split it into 2 sheets of paper. So you'll have 2 half sheets, just like this. And then you only need one of them. So go ahead and put one to the side. And then you're gonna go ahead and fold your half sheet in half. And do this just like you did before. You get a nice thin rectangle. And you want a nice crease so that you can once again split this into 2 pieces of paper. Now you only need one of those. So once you have one, the next step is to fold this in half one more time, but this time we're not going to be cutting or tearing anything. Instead, we're going to draw a line right down the middle, just like so. Okay, so then we're going to rotate it and we're going to look at the bottom section and we're going to split it into thirds. So you're going to have to kind of guess about where it splits into thirds, but you're going to mark it off. And then we're going to draw a line all the way to the bottom of the paper. Just like that. Great. Okay. Now once we have these 3 lines, we're going to focus on the top half. So what I'm going to do is I'm going to find about the center of the paper. So let's see. Here's about the center. And I'm going to draw a line to either side. Now I want to leave a gap between these 2 lines. As I draw this, it kind of looks like the top of a house or the top of a triangle. And then from the point of that, you're going to draw a line straight up. Perfect. Okay. And if your lines aren't perfect, that is okay. But if you choose to, you can use a ruler to draw them. All right, now the last step before we begin cutting or folding anything, we need to mark where we're going to cut because we don't want to cut the wrong things. So I'm gonna actually take my pen and draw a little circle right on either side. So that means I'm gonna cut this little section right here and this little section right here, just that line, that's it. And then I also wanna cut this top section. Okay, so once I've marked those, I'm gonna grab my scissors and cut carefully so that I don't cut the wrong thing. So just this little section, and then we'll cut this little section, and then our top portion, just down to that point. Perfect. Now that's all we're going to cut, nice and easy. And then we're going to begin folding. So let's start with the bottom. We're going to use those lines we drew as our fold lines. So we're folding in, so you can see now why we split it into thirds. Oh, not too bad. All right, and then I'm going to fold the other side in, just like so. So this is the bottom of our helicopter. And then I'm going to fold the very end up just a little bit to give it some weight, like so. Just like that. Not perfect, but that's okay. Now we look at the top. We need to fold our blades of our helicopter down. So we're gonna fold along those lines we drew. So I'm gonna fold one of them forward. Then I'm going to flip my helicopter over. And I'm gonna fold the other one backwards. Now, if you get confused at all, you can always check once you're done folding them. Make sure you've got one blade going one direction and one going the other direction, just like that. Perfect. Now we're gonna reach up really high and let it fall. So it gets a nice spin on it. So what you can do is you can take your helicopter, if you haven't dropped it on the ground, and you can try it out. Reach up really high, stand somewhere where you're not gonna hit anyone, and see how it flies. Now, maybe you'd like to change it, or maybe you'd like to see how it compares to other things that you might drop. So try dropping it at the same time as dropping a plain piece of paper. And then ball that paper up into a ball and drop it at the same time as your helicopter. And then you can make all sorts of new designs and get new ideas just like a NASA engineer would. Good luck with your helicopter and have fun!
To get more details about this activity and other Mars resources, check out our Mars 2020 STEM Toolkit online.
Wow, perseverance and ingenuity are true examples of pioneering science at its best. Don't forget to check out our Perseverance rover launch in July of 2020. And thanks for joining me today. For NASA at Home, I'm Lindsay Thornton. See you next time.